So we will discuss the theorems on angles formed by tangents and secants. So when we say tangent, it is the line that touches the circle once. And this point here, where it intersects the circle, is called the point of tangency. While secant intersect the circle or touch the circle twice. Okay, so let's move to our first theorem. Now, for our first theorem, if two secant line intersect inside the circle, okay, the sum or the half of the sum of these two opposite arc or intercepted arc is the measure of this angle. Now, if it's the measure of this angle, then it is the same as this because they are vertical. Okay. Now let's call this the angle 1 and angle 2. This W, R, X, and S. Okay. Now as I said, the measure of angle 1 is equal to 1/2 of arc WR plus arc AS. Okay, so let's say this is 100 and this is 120. So if we substitute, we get 1/2 of WR, which is 100, plus 120. Okay, so that is 1/2 of 220, which is 110 degrees. So meaning this is 100 degrees, 110 degrees, and this is 110 degrees also. Okay, now this is easy to find to the value of angle 2. So let's move to our next theorem. Now, if two secant intersect the circle at exterior of the circle, okay, the formula is almost the same. But in this case, since the intersection of two secant is at the exterior of circle, we will subtract the two intercepted arc. Okay, so let's say this is x, this is y, this is n, and this is m. Okay, and the formula to find the value of angle P is the 1/2 again of the bigger arc or the larger arc, which is arc xy, minus, since this the intersection is outside, so we will subtract. Now that is intersection of, arc of m and n. Okay, let's say that the value of xy is 140 and m arc mn is 30 degrees. Okay, so measure of xpy is equal to 1/2 of arc xy, which is 140, minus arc mn, which is 30. So that is 1/2 of 140 minus 30, that is 110. And 1/2 of 110 is 55. So angle xpy, or this, is 55 degrees. Let's move to our third theorem. For our third theorem, we have if one secant line, okay, and a tangent line. Oh, wait. Yeah, that is a tangent line. So if they intersect outside the circle or exterior of the circle, then same concept, we will subtract their intercepted arc and multiply it by a half. Okay, so let's say this is x. This is, wait a minute. This is C, L, M, and G. Okay, so the formula for this, if we want to find the angle of CML, is 1/2 of the larger arc, which is CL, minus, okay, since exterior angle, the value of smaller 1, which is from L to G. Now, let's say the value of CL or arc CL is 186, and the measure of arc LG is 70. Okay, so let's find the value of angle CML. Okay, so measure of angle CML is equal to 1/2 of the bigger angle, which is 186, or bigger arc, I mean, minus the smaller one, which is 70 degrees. Okay, so 1/2 of 186 minus 70, that is 116 degrees. And 1/2 multiplied to 116, that is 58. So therefore, our angle of CML, that is 50 degrees. Okay, so on to our next theorem. So let's say we have a circle here and a secant line, and the point of tangent C is at the one of the intersection of circle and secant. So let's say here, okay, there. So how do we measure this, and how do we measure this also? Okay, so let's say the intersection or the point of tangent C is S, this ray is R, W, this is Q, and we have a point T here. Okay, so how do we find the measure of QSR? Okay, if this arc is 170, so to find the value of angle QSR, we must be first familiarized with the formula in this scenario. Now, if the intersection is at the circle, okay, we don't need to subtract or add, okay? We just set the value of intercepted arc to half, because the value of arc or the intercepted arc is half the value of the angle. So the measure of QSR is just 1/2 of the RQS. Now, measure of QSR is equal to 1/2 of QS, which is 170, and half of 170 is 85. Therefore, our measure of angle QSR is 85 degrees. So on to our next theorem. Let's say we have a circle here and two tangent intersecting outside the circle. This is point J, this is K, this is J, this is Q. Okay. So how do we find the measure of angle KQH? So this is the same concept as the two theorem before. Since since the angle is outside the circle, okay, we will just find the difference of the larger one, okay, which in this case that is arc HJK, so minus the value of the smaller arc, which is arc HK and multiply it to a half. Now, 1/2 of arc HJK, for example. Now, let's say pala that HJK is 250. And, okay, since this is 2 tangent, therefore, this part here is 360 minus 250. That is 110. Okay, so HJK, okay, is 250 minus 110 for arc HK. Now, 250 minus 110 is 140 degrees. And half of 140, that is 70 degrees. So meaning, the measure of angle KQH is 70 degrees, which is here. Okay. Now for our last theorem, okay, this involves the concept of vertex or inscribed angle. I mean, yeah. So let's say we have a circle here. That's not a circle. Again, let's have a circle here. Okay. Then two secant intersecting at the circle. Okay. Now if we ignore these um, extended lines, we can say that this is an example of inscribed angle. Okay, so when we say inscribed angle, the measure of this angle here is double the measure of its intercepted arc. Okay, so if we say this is B, C, and A, okay, the measure of angle ABC or ACB is equal to the half of arc AB. Now let's say the arc AB is 120, and if we substitute it to our formula, measure of angle ACB is equal to 1/2 of arc AB, which is 120. We will get a value of 60 degrees. So that is our answer. So just take note that if the angle is interior or at the interior, we add or just 1/2 of A plus B. But if it's in the exterior, okay, this is the same, different thing, but same concept. In this case, we just subtract it. But if the angle is at the circle, okay, we just get the half of 8 or the given arc without subtracting it to other. So that's it for our theorems on angle formed by tangents and secants.